So, hello, I'm Adam. I'm Head of Chemistry at Cardinal Newman, and I'm going to explain a little bit about our chemistry course that we study. So it's A-Level Chemistry. It's with the OCR exam board. Our specification is Chemistry A. It's a linear course, so there are 3 written exams which make up 100% of the grade at the end of the 2 years of studying chemistry with us. Within the linear course and the learning for these 3 exams, we study 6 modules across the course. Module 1 is development of practical skills. Across the 2 years of the course, we would be studying experimental techniques, practical methods at different points where that relates to the subjects that we're studying in class. So it's very much about developing confidence and competence and being able to carry out experimental techniques well, to record results appropriately, to be able to manipulate equipment, and obviously different experiments would fit in with different topics across the 2 years of the course. Module 1, practical skills. Modules 2, 3, 4, 5, 6 develop exam content theory. So that would be Module 2, the foundations of chemistry. Module 3, we're looking at developing some ideas that you'll be familiar with from GCSE studies, so rates of reaction, chemical equilibria, exploring these topics in a little bit more detail, starting to get a little bit more quantitative in the way we look at these, so math skills become very important within the course. As we move to Module 4, core organic chemistry, and modules 5 and 6 that we focus on in the second year of the course develop those topics even further. So module 5, further physical chemistry, and module 6, further organic chemistry. So a topic would probably start with the exploration. There'd be exercises and activities which would look at applying the learning to exam style questions, inputting advice on exam technique. Within an exam, 20% of the marks available are going to be looking at level 2 math skills. About 15% of the marks in the exam component will be looking at practical skills and awareness of the experiments. So we do embed discussion of practicals within theory lessons, and then every few weeks when it becomes relevant to the topic or relevant at the point in the year, we will have a practical lesson. And a practical lesson would explore an experiment relating to ideas, which a student chance to maybe plan the method or carry out a method that we're giving to the class to gather results and then to analyse those results, and that can really bring the theory, the ideas to life in many cases, and also develop important skills. For students wanting to progress to study science at university, practical skills are really important. Many universities are asking for a pass in the practical endorsement alongside a grade in the A-Level Chemistry. So subjects that students often look to study alongside A-Level Chemistry, good combination of subjects. I always hesitate when asked this question because I want to put in here the advice that you mustn't choose subjects that I have listed simply because we're saying that's a good combination. Please do think about what do I do well, where are my strengths, where's my skill set. Whilst it's certainly true that students who may be looking to apply for prestigious courses, medicine, dentistry, vet courses, chemistry A-level is a required subject, and many students will take maths or biology alongside, it's not always right to take that set of 3 subjects. Chemistry can be taken alongside maths, physics, biology, or core maths, as well as blended with other subjects from other disciplines across college. Courses that students move on to study from chemistry, biomedical science, biochemical science, chemical engineering, and also subjects which are less linked to science. So for example, accountancy, law, management subjects which really pull on the analytical skills, the numerical skills, the problem solving skills that we develop within A-Level Chemistry.
I really like chemistry because it's involved in everything we do, especially organic chemistry, which is the study of organic molecules and how they interact with each other and everything around them. For example, you can use analytical techniques to look at different molecules in your system. So on TV, quite often see on like police programs of people who've been driving and getting breathalyzed, and that will show you if there's any alcohol or drugs in their system. And I just like how it all, kind of knits together with real life. So after college, I want to go to university to study pure chemistry with a master's degree. I'd like to do this at York University, providing I get the grades.
I am Sam, and I'm currently studying chemistry, maths and German, and I'm also student union president here at Newman. I think the best thing about chemistry is the fact that it's all around us. Just because we can't see what's going on doesn't mean it's not happening. So I think really understanding why something happens the way it does is a really fundamental part of chemistry and one of the reasons that I enjoy it so much. I'm hoping to study chemistry at Imperial College London and also do a bit of German there as well. But I'm also hoping to specialise in the future in medical chemistry, so drug development and how that will help in the future. So here at Newman it's not just about studying the subjects as well, there are other things you can do. So I joined the student union last year and then this year I was made president. And I think that that's just shown me that here at Newman the students have such a voice that they can make a difference to learning and other things around college. So for example, we do lots of charity events in which we're raising money to help people not only around college but in the local community, such as the elderly people.
Most staff, most teachers at Newman will be convinced that their subject is the best subject in the world, and obviously chemistry is the best subject in the world. Why is chemistry so important? If we just think about so many things that we take for granted in our daily life, the clothing we're wearing, plastics, polymers, chemists developed these and we use them in so many aspects of life. And just picking up on that idea of plastics are non-biodegradable. We created a problem. Chemists then had to develop solutions to that problem and evolve these ideas. And so whilst a lot of chemistry that we study in the course is traditional chemistry, it is also touching on topics which impact society, impact the world today. We're going to need medicines for the future. We're going to need chemists who are working in labs to design and develop pharmaceuticals, develop materials for the future.